The Etex group of companies provides a comprehensive range of facade claddings to fit all shapes and sizes of buildings. These claddings are used as a rain screen. Rainscreen, which is also referred to as a ventilated facade, is a kind of two-stage construction. An inner structure with a protective outer skin. This skin protects the structure against the elements. With the placing of the insulation on the outer face of the structure, Rainscreen also meets the challenges of modern construction in terms of preventing thermal bridges, dissipating solar gain, reducing thermal movement of the structure, resisting moisture and humidity, preventing internal condensation. By using our panels as the protective outer skin, we also give the buildings the added feature of looking good. Rainscreen is ideal for use in both new buildings and renovation projects. Many people think the whole Rainscreen concept is a new phenomenon. Rainscreen cladding started out in Norway. It was not a scientific breakthrough, but more a gradual discovery that happened centuries ago in a largely intuitive way. Norwegian builders, probably through trial and error, found a way to utilize drained and back-ventilated cladding with joints which were both closed and open. This approach was called the open jointed barn technique, since it was originally used in the construction of barns. The timber cladding had openings at the top and the bottom of the timber to allow water drainage and the evaporation of any rain. Scientific research of the underlying principles of a rain screen didn't start until the 1940s. It was quickly recognized that the principles involved in rain screen cladding were vastly superior to anything else in use at the time, and that still holds true today. Early research concluded that it is unwise to allow walls made of brick or concrete to be exposed to heavy rain. The porous nature of the materials acts like blotting paper and absorbs water. Fitting an outer screen to the wall that could repel rainwater was adopted. Today, the potential problems caused by global warming can easily be addressed with this building technique. During the years of research, two techniques emerged: pressure equalized, which is more common in North America, and the more familiar European drained and vented open joint rain screen. Pressure equalized systems need to calculate the wind has on each facade. These forces are controlled by incorporating baffles in the cavity and the joints in the cladding assembly. This regulates the airflow. This method limits the choice of cladding material and is more complicated to design and construct. The drained and back ventilated technique is the simplest form of rain screen and is favoured in Europe. It consists of a thin impervious flat sheet fixed to a supporting frame which forms a clear cavity between the panels and the insulation. The joints can be open or lightly baffled. The special thing about the drained and back ventilated approach is that the cladding is allowed to leak. any water that may penetrate the joints and enter the cavity behind the cladding is quickly evaporated through the natural ventilation in the cavity or by draining down the back of the panels and out at the base of the wall. In driving rain conditions, the moisture forms a membrane across the joints which keeps most rainwater on the outside of the panel. Scientific testing carried out by FVHF from Germany has shown that the amount of driving rain that ever reaches the face of the insulation is minimal. The effectiveness of any Rainscreen system can be checked by standing at the base of a large installation in the driving rain and observing how little water emerges from behind the Rainscreen cladding. In addition to the outer skin, a number of other elements need to come together. Starting from the inside, the internal structural wall can be of masonry or lightweight construction. It needs to be airtight and to withstand the wind loads that will be placed on the building. The insulation thick enough to suit the building's function should also be suitable for Rainscreen use. Ideally, the insulation should be fireproof and permeable to allow any water vapour to pass from inside the building into the cavity. This needs to be securely fixed to the structure and fit tightly around the supporting frame. The supporting frame should be designed to carry the panels and a certain amount of wind loading. This supporting frame is commonly of aluminium, galvanized steel or timber battens. The ventilated cavity should be of adequate size to provide both air movement to evaporate moisture and vapour and a drainage path for water to run down the rear of the panels and out at the bottom of the cladding. Air must be allowed to enter at the base, travel unobstructed up the wall and exit at the top of the building. Now for the physics bit. By placing the insulation on the outer face of the structure results in a number of benefits for the building. Notably, in wintertime it keeps the building warm and the cold air is prevented from affecting the building structure. In summer, the ventilated Rainscreen has a cooling effect when outside temperatures are high. Most of the sun's rays are reflected away from the building. Heat that passes through the panel is partially dissipated by the ventilating effect in the cavity. An additional benefit in controlling temperature is that the structural movement of the building is minimized. Acoustic performance of the wall is increased when compared to other forms of construction. In conventional construction with internal insulation, the thermal shield has weak spots where the floor meets the wall. These are called thermal or cold bridges. This results in heat loss and can cause surface condensation, which can lead to mold growth. By having the insulation on the outer face of the wall, it can be easily mounted without interruptions. Therefore, any thermal bridges are eliminated. The Rainscreen system is very efficient in controlling condensation. Any risk of interstitial condensation occurs in the ventilated cavity. The breathable structure allows water vapour to pass through the construction from the inside into the ventilated cavity. All of this results in a greater degree of comfort for the occupants and ensures a healthy building. Climate change is of course a big issue. As you have just seen, Rainscreen is most suitable in meeting the demands in many climates. The drained and ventilated Rainscreen that we promote does not need the use of any special sealants and relies on simple techniques to work. Tougher standards and regulations can easily be met with Rainscreen. Rainscreen is adaptable and will meet the needs of any changes in architecture, fashion or construction methods. ETEX has been at the fore of Rainscreen development for many decades and has built up a vast knowledge. Its panels have been successfully used in many projects in many different climates the world over. We offer cladding solutions to fit all shapes and sizes of buildings that ensure the screen is lightweight, strong, durable, excellent resistance to fire, frost-proof, resistant to fungi and insects, minimal maintenance, and is also aesthetically pleasing. Just because its primary purpose is to serve as a Rainscreen, there is no reason why it can't look good too.